everyone, welcome back to our YouTube channel Becoming a Rose Developer. I'm Desire, and today I've got Ahsan, who has just completed the course Linux Basics for Robotics, and he'll be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so he can begin his presentation. Alright, whenever
Okay.
you're ready.
Yeah, I'm ready.
Yeah, okay,
Can we start?
yeah, you can begin your presentation, yes.
Okay. So my name is Yasin Ali, and I have completed the course on the Construct Academy of the Linux for Robotics Basics course, which is a course which teaches you about how to get started with the Linux, particularly for the robotics. And during this course, I did a project which
Mm-hmm.
was the project of this course, and in that we have to deal with the two kinds of environments. One is the simulation environment, and the other one is the physical robot environment.
Mm-hmm.
So what we are going to do is today that I'll be presenting first the simulation environment, and then then about my project in the real environment as well. For that, I have already done the booking. So for the simulation environment, I'll be executing first first part, the all the parts of the project so far.
Mm-hmm.
Robot.
Alright, so can you explain to us what you're doing?
Wait. There is a bit of a problem with the can with that. First, we have to source the environment for the simulation. I'll be just going here. Wait, never mind.
I think let's start with the real robot, right? We can come back to the
Okay,
simulation so that we don't run out of time.
okay, sure. For that, wait. Because here, okay, let me hide this, and there is a real robot. Connect. So we'll be using, oh, it's connecting to the joystick. I'm gonna run the commands for that. We have the three files: robot interface .py. We had also simple petrol for real robot, and the other one is for simulation.
Okay, and this script that you're running, what does it do?
In this first script, the robot interface, this script is basically about it setups the environment for the robot, and this is the script which is provided over here. You can see it from. Wait, let me just show you.
Yeah, okay.
Yeah. So this imports the Python library, which is ROS client libraries, Python. It imports the nodes and everything, and then we have the sensor messages from IMU, which we have ignored. There is the function which is called the robot interface node, and this node is basically responsible for getting the information for initializing the interface
Mm.
and setting up the environment. And this you can see that it scans the angle for minimum, maximum, everything, the increments, the range of the lidar which is mounted, the position of the robot, and other stuff.
Mm.
So in the second terminal, I'm gonna run I'll be running the robot, but first I will be just positioning it according to the. It's not working.
Try using teleop.
Sorry.
So go to the terminal and run ROS2 teleop twist. You've used that before, correct?
Yeah, yeah, yeah.
Okay.
ROS to run the log keyboard.
You left two there. It's teleop twist keyboard. So
Sorry.
ROS2 run. So you've got a 2 missing in front of ROS. An underscore keyboard, yeah.
In some places in the course we use a ROS2, but in some cases we use a ROS1. I didn't understand the.
Yeah, your current project is using ROS2, right? So,
So I can control the robot from here.
can you move it?
You see the values are being changed.
But does it move forward? Can you press?
Mm. Yeah, I'm pressing. You can see the values are changing, but the physical robot is not moving.
Okay, all right. Okay.
There is.
Can you run
I don't know.
ROS2 topic list to see if we are connected? Maybe try this.
Try to disconnect.
Yeah, and then connect one more time after that.
Yeah, yeah. So let me just retry. Now it's moving. Yeah, but let me just place it again. The same problem.
Try running your obstacle bait and your base script, and let's see.
Okay.
Okay, let's see the statistics script.
Yeah,
Concurrently,
you
so
can
it's running.
see.
Oh, you integrated it into one script. Okay,
Yeah.
okay, that's good.
So it's basically detecting the obstacle,
Mm-hmm.
and if there is some obstacle, it will avoid it and try to move right or left according to the conditions. But first, it's scanning its environment,
Mm-hmm.
getting the front range and the front free distance to move, that how many distance it has to cover,
Mm-hmm.
and the time it will decide based on the batch script we have written.
Mm-hmm.
And I can just show you some things in the code in the IDE we have. This is a real one, simple petrol real. So it's we have the getters,
Okay,
which
so
is used to set the.
let's do this. So let's have your IDE on the left and then the robot running on the right so that we don't lose sight of both of them, right?
Okay.
And then you can have the other half
Yes.
show your IDE. And
Yeah, yeah, sure. So it's good.
yep, all good. Yep.
So we have the getters, which are the functions, but first we have written the shebang script, which tells the file that this is a bash file. If it's a Python file, we'll just change by with the Python or C++ according to the file. We have file type that this is a bash file dot bash. It's written over here. You can see. Then we have the getters, and these getters are provided in the notebook. You have all the information which is being listed over here, and we can use these getters. Uh, we can use these getters to create our bash script, which is provided in the course. This one, but wait, yeah. By the way, these getters, these were provided in the notebook for the project.
Mm-hmm.
And this is the scan right. This getter scans the right of the right range of the laser, and front. Also, you have the front tray, front right, front left, and command velocity linear. This is the command for setting up the wheel and velocity and everything. This is the angular for linear and angular. These are measured in radians per second and all that. Then this echo command is basically printing that running simple robot patrol with the batch script, and this also prints a control C to terminate. You can see when it was started. Uh, there was written like you can press control C to terminate. I think in the very beginning.
Yeah, yeah, no worries. So let's go on.
And then we have the all these the threshold is such set for 0.300, which is basically in meters. So it's 0.3 meters. And then this one I don't really remember, but these are all the files. And do the front scan. It's the front scan range, then the front free range and everything. And finally we have the setters of the code which were provided, and these were basically just three.
Mm-hmm. Okay, so let's do this. You can stop the robot from moving or just terminate your obstacle avoidance script. And then, no, don't disconnect. Okay.
Ah, I disconnected, sorry.
What I want is I wanted you to maximize your IDE and then you go through the logic of how the decision to turn is done, right? So click the green button to see the full IDE.
Sorry.
Maximize the IDE, so the green button on the top left.
Okay.
Yeah. So in this, right, I believe this is where your obstacle avoidance logic is happening, right?
Yeah, yeah, yeah.
Yeah. So given the way it was moving, right, can you take me through the steps of how it decides where to turn and how long to go for? Because I noticed that in when your robot was moving, even though the front was
Yeah.
still clear, it wasn't moving continuously. So can you take us through the process? Why is that happening, and where in the code do you control that?
Okay, in this that while loop, it's scanning the front range of the laser, and it echoes the front range, which is basically in meters. It's shown over there on the terminal, and checks for the front checks if the front range is under 0.300 zero point 0.3 meters. So it will check this, and then it will also check the front free range, which is check if the front range is less than the threshold cell, which is the 0.30. And after that we have the range, and it equals the left range of which is obviously in meters. And then we have this. Finally we have the if function. If the left range is greater than the right is greater than the right range, then echo turning left. The robot will turn left, and the command velocity command angular will be set to 0.9427,
Mm-hmm.
which is basically to move the wheels. And if this is not the case, if the left range is less than the right range or equal to the right range, then the robot will turn right,
Mm-hmm.
which
How
is
was
the
the so?
threshold, which is 0.94.
All right. So tell me, how did you choose the value 0.92477?
And this is provided in the I think in the instructions
Mm-hmm.
for that.
And why that specific value, right? What is the logic behind choosing that value as your turn angular velocity?
This is angular velocity in radians for the robot to move with the specific speed.
Mm-hmm. But why that value? That's what I'm asking. Why that value? Why not any other? Why not one, two, three?
Yeah.
Why not any other value?
This is because I just took help from the notes.
Okay, so here's what I'm looking for, Asan. When you
Yeah.
use code that's
Yeah.
given to you in the course, right? I expect that you have to have a thorough understanding of what it's doing, right? So
Okay.
this is why I'm asking, why did you choose that value? Why do you not just choose zero point 0.5, for example? That's a very random number that I can set as my angular velocity, right? So there's a clear logic behind that, right? Even from the code that you used, there's a reason why we give you that value, but we don't expect you to use it without understanding what it's doing and why you have to pick that specific one, right? You have to give
Okay.
some justification of why, because you are the user of the code, right? We
Yeah. Yeah.
can't go against you using it, but what we want you to do is to understand what you're doing in the process. That's why I'm asking this question.
Yeah. I understand, but this is just I took help, so I said this one.
Hmm. Hmm. Okay. All right. Let's go on to the other stage. You can explain what's happening when you get an obstacle on on another side.
So when we get out of the loop, when the loop breaks, and this is if else condition we have used. So after that, if this is not the case, the robot will echo just the distance to move, and this is the front range and the threshold set, and also time to move. How much time the robot has moved, the distance to move, and time to move will be echoed on the screen, and the robot will also echo if it's moving forward or moving to the right or left.
Okay. All right. All right. So let's see your robot statistics. All right. All right. All right. So let's go back to the top.
Yeah.
So on line 4, right? Can you tell me what that line does?
So basically, we can in batch scripts we can use the commands we can use on the terminal.
Mm-hmm.
So if we use in the terminal like source dot robot functions dot bash, it will source the robot functions bash file, which is over here, and this will automatically in this batch script, this file will be sourced and can be used without typing it again and again, without typing all the code of the robot function which is provided over here. We can just simply use that command in this to run the code of the robot functions dot bash over here, and to use it over here for our next steps.
Mm-hmm. Mm-hmm. All right. All right. Okay. So thank you very much, Hassan. So we won't be able to do the simulation demo, but at least we've seen what the real robot stuff worked. Right. So what I'm gonna do is we're gonna wrap up the presentation here, and we'll continue our conversation on Zoom. All right.
Yeah.
Alright everyone, this was Ahsan's presentation, and I'd like to encourage all those of you who would want to try this course to do so, and then you can also come and showcase your work. So until next time, keep pushing your Roche learning. Bye bye.